Oh, so this class is a continuation from last class, and last class we began the system and we learned muscle groups of it. Today we are going to continue with types of muscles, the characteristics of muscles, and skeletal muscle structure.
Mm-hmm.
All right, so can you see?
Yeah.
All right, so first thing we're doing is types of muscles. Oh, technical difficulties. Yeah. Ooh! Okay, so we have three types of muscles in our body.
Mm-hmm.
Skeletal muscles, cardiac muscles, and smooth muscles.
All right.
Right. Now, our skeletal muscles are classified as voluntary muscles.
Yeah.
Right. And it have a striated appearance. Which means,
Who appearance or striated appearance?
yes.
Like skeletal muscles. Mm-hmm.
Our cardiac muscles now is involuntary,
Mm-hmm.
and it also has a striated appearance.
Okay.
Now, our smooth muscles
Mm-hmm.
is considered involuntary,
Yeah.
but it's not striated in appearance.
Not striated appearance. Nice.
The simplest way to remember this would be like to have it in a table. So let's
Mm-hmm.
do that here. Let's do that now. Let's draw up a table where we would have the types of muscles on one side, and then we would have sort voluntary, involuntary, striated, and unstriated. And that way, under skeletal muscle, you would put a tick by voluntary and striated. Under cardiac, you would have a tick by involuntary and striated. And under smooth, you would have a tick by involuntary and unstriated. You understand what I mean?
Yeah, I hear you.
You hear me, but do you understand what I mean?
In making a table.
Yes. Well, when you make a table, it would be easier to remember than to just try to remember it as it is here.
Yeah. So I put in the skeletal muscles,
Mm-hmm.
and in one area,
Okay.
in one column. Then I put in the cardio
Cardiac
muscles,
muscles, yes.
cardiac muscles,
Mm-hmm.
and smooth muscles
Yes. Each of them in a different column.
in a different column, right?
Right.
We put in whether it's voluntary or involuntary
So
under each.
you know how a table is? It's like rows and columns, right? No, columns, rows, right?
The same thing.
No, rows goes across, columns goes down, right? So
And you create a table.
column, you would have the skeletal muscle, the cardiac muscle, and the smooth muscle, right?
Mm-hmm.
And in the rows now, you would have voluntary, involuntary, striated, unstriated.
Mm-hmm. And
Right,
we put whether these muscles fall in these categories.
right. So you have skeletal
Mm-hmm.
muscles, right, which is voluntary and striated. So you put a tick by voluntary and you put a tick by striated to show that it's voluntary
Mm-hmm.
and striated. And you do the same stuff with cardiac and smooth muscles.
Yeah. How do I know?
Yeah, you could do that now. Take a little
All
think.
right. So, cardiac. Voluntary. Involuntary. And striated. The next one. Yeah.
Yeah.
Voluntary and striated. Involuntary and striated. And the smooth is involuntary. You didn't give me the information for smooth.
It is involuntary and unstriated.
Okay.
Okay?
Yeah.
So simple to remember.
Yep. Very simple.
Alright. So the next things we are going to be doing today is the characteristics of muscles or the properties of muscle. Right?
Mm-hmm. Voluntary.
So muscles. Okay. So the first characteristic of muscles is contractility, and this is the ability to shorten or contract. Very simple.
Oh, what? What?
Contractility.
Contractibility.
Contractility.
Yeah.
Right? And that is the ability to shorten or contract.
Uh-huh.
Simple enough.
Yeah.
Um, the next would be excitability.
Well, some big words there. Way. Yeah.
That is the
The
ability
ability to reduce.
to respond to a stimulus.
Oh, they respond. I didn't see that word, you know. Mm-hmm.
Right. The next one is extensibility, and that is the
Sensibility.
ability to stretch or extend.
Uh-huh.
Right? Got that? You with me so far?
Yeah.
Okay, so the next one is elasticity,
Mm-hmm.
and this is the ability to return to its resting shape after being stretched. So this is like, okay, after you stretch your muscle, you don't want it to remain in that stretched position. You would want it
Mm-hmm.
to into its normal
To
length.
come back.
Right.
Yeah.
That is elasticity. And the last one is adaptability. And what we mean by adaptability is that it can change in response to how it is used. For example, if it is you work out every day, your
Mm.
muscle would grow, not so?
Yeah.
But if it is you don't work out, or if let's say you started working out every day for like a month and then you stop, what would
Mm.
happen to those muscles?
It will
Right.
atrophy.
It would waste away, right? So
Yeah.
that is basically what adaptability is. It's the ability to change depending on how often it's used. Right?
Yeah.
All right.
The ability to change in response to how you use. Alright, okay.
Understood?
Yeah.
All right. So the next thing that we're going to do now is contraction of your skeletal muscle, right? Now we see before that both cardiac muscle and smooth muscles were involuntary, that we don't control those, right? Our
Yeah.
skeletal muscles, however, is the one that we control. And
Mm-hmm.
I have a short video explaining what
The
is,
process.
yes, what is muscle contraction. And then we are going to have a short discussion on the video. So please pay attention and make notes or anything that if you have any questions for after, okay?
Mm-hmm.
You use muscles every day to do activities. This woman is using muscles to breathe, circulate blood, and move her hand to take notes. Your cardiac and smooth muscle tissues are involuntary. You do not consciously control their actions. Skeletal muscle works under voluntary control. Skeletal muscles are composed of bundles of muscle fibers. Muscle fibers are long cylindrical cells containing several nuclei. Muscles will contract or relax when they receive signals from the nervous system. A neuromuscular junction is the site of the signal exchange. This is where the synaptic bulb of an axon terminal and muscle fiber connect. Muscle fibers are composed of many myofibrils. A myofibril contains contractile units called sarcomeres. Sarcomeres run adjacent to one another down the length of the myofibril. Each sarcomere consists of alternating thick and thin protein filaments, giving skeletal muscle its striated appearance. The muscle contracts when these filaments slide past each other. The thick filaments are myosin, which are anchored at the center of the sarcomere, called the M line. The thin filaments are composed of the protein actin, which are anchored to the Z lines on the outer edges of the sarcomere. Because the actin filaments are anchored to the Z lines, the sarcomere shortens from both sides when actin filaments slide along the myosin filaments. Although the action between the filaments is described as sliding, the myosin filament actually pulls the actin along its length. The cross bridges of the myosin filaments attach to the actin filaments and exert force on them to move. This action is known as the sliding filament mechanism of muscle contraction. In this model, the sarcomeres shorten without the thick or thin filaments changing in length. A contraction begins when a bound ATP is hydrolyzed to ADP and inorganic phosphate. This causes the myosin head to extend
ATP
and can attach to a binding site on actin, forming a cross bridge. An action called the power stroke is triggered, allowing myosin to pull the actin filament toward the M line, thereby shortening the sarcomere. ADP and inorganic phosphate are released during the power stroke. The myosin remains attached to actin until a new molecule of ATP binds, freeing the myosin to either go through another cycle of binding and more contraction, or remain unattached to allow the muscle to relax. Muscle contractions are controlled by the actions of calcium. The thin actin filaments are associated with regulatory proteins called troponin and tropomyosin. When a muscle is relaxed, tropomyosin blocks the cross-bridge binding sites on actin. When calcium ion levels are high enough and ATP is present, calcium ions bind to the troponin, which displaces tropomyosin, exposing the myosin binding sites on actin. This allows myosin to attach to a binding site on actin, forming a cross bridge. Calcium ions are stored in the sarcoplasmic reticulum and are released in response to signals from the nervous system to contract. Neurotransmitter molecules are released from a neuron and bind to receptors, which depolarizes the membrane of the muscle fiber. The electrical impulse travels down the T tubules and opens calcium stores. Calcium ions flow to the myofibrils, where they trigger a muscle contraction. As the actin and myosin slide along each other, the entire sarcomere shortens as the Z lines draw closer to the M line. As the sarcomeres in myofibrils contract, the entire muscle fiber will shorten. When muscle fibers contract in unison, a muscle can produce enough force to move the body, allowing you to take notes.
So, tell me what you got.
That was plenty.
I know it's a lot to take in, but
All right.
what it is you got from this?
So, what I now understand is why we need to have calcium in our body, because it helps with muscle contraction. I didn't know that all that chemical reaction is happening inside there. But next thing I learned is that the nerves or the nodes sends electrical impulse to the sarcoplasmic reticulum. I think that's the word she said. To send a message. Well, and when that signal goes through, it goes through the T tube and it sends that signal through the whole muscle. I think it'll be sarcomere in that case, yeah. So I found those the more interesting parts to me after watching the video.
All right. So you seem to have like a little mixed up with the information. Like I guess it was a bit too much to give you all at once. So
Mm.
let's do like a breakdown of how exactly
Right.
muscles contract. All right. So let's go with the electrical impulse, right? So now, as we see, we need to send signals to that body part for it to move because it's not involuntary. It's a voluntary action, right?
Mm-hmm.
So our electrical impulse travels down to your synaptic gap, right? But
Yeah.
your synaptic gap is a junction that we see that electrical impulse can't cross, right?
It can cross.
It cannot.
Cannot, right?
No. So when it travels down to the synaptic gap now, it stimulates for a chemical that could cross the gap to be released, right?
Mm.
Understand what I'm saying so far?
Yeah,
All
getting
right.
clearer.
So that chemical, ACH or a tetrachlorine, you could just use
Mm-hmm.
ACH if it is you can't pronounce the words too well, right? So that chemical is released, right? Now that chemical is able to cross that gap. So it crosses that gap and it goes down to the muscles, right?
So the electrical impulse,
Mm-hmm.
well, as I say, it travels through the synaptic gap, right?
Down to,
Down to the synaptic gap,
yes,
and ACH is being released.
right,
So it will pass through that gap.
right.
All right, nice.
Mhm.
Mm-hmm.
Right. So now what ACH does is that it opens the sodium gates. Now sodium is a positively charged ion, right? We know this.
Yeah.
So when it opens the sodium gates, sodium comes in and your cells become positively charged, right?
Mm-hmm.
Now this positive charge is called action potential. Like this is the potential for the muscle to contract, but it's not exactly there yet, right?
Action potential.
Yes. With me so far?
Yeah. So ACH open the sodium gate,
Mm-hmm.
which we know sodium is a positive charge
Mm-hmm.
ion, and when this happens, it gives not the opportunity, but it acts, not acts, but as a action potential or
Yes,
potential for muscle contraction,
r-
basically. So it acts as a potential for muscle contraction.
right. Now, this action potential then travels down to the T tubule, down the T tubule. You know, we
Mm-hmm.
saw what the T tubule is in the video, right?
Yeah.
So, and that goes to your sacroplasmic reticulum. Now, your
So the
sacroplasmic
TT, so the so the
potential,
sodium, right? So the action potential It goes through the T tubule.
Yes.
Well, like the sodium, the sodium, the sodium. The sodium, man.
I'm not sure what you're talking about.
With the action potential. What
Right.
does go through the T tubule?
Your action potential goes down the tubule.
Oh, okay. All right. Okay, makes sense now.
And it goes to your cytoplasmic reticulum.
Cytoplasmic reticulum.
That's in your sacrum,
Action.
right?
Yeah.
Now, your cytoplasmic reticulum is responsible for storing calcium.
Mm-hmm.
With me so far?
Yeah.
Right. So this action potential travels down to the cytoplasmic reticulum and it stimulates the cytoplasmic reticulum to release calcium. To open up the calcium stores.
All right, hold on. So when it goes through the T tubule,
Yes.
it opens. What it opens?
It opens calcium stores, but your
Right, calcium
calcium
source.
is stored in your cytoplasmic reticulum.
Oh, okay. All right. So it enters your cytoplasmic reticulum,
Yes.
which has calcium and which opens your calcium stores.
Right. Right. So as we saw before, calcium is needed for muscle contraction, right?
Yeah.
So calcium, when calcium is released, it goes to troponin, right?
Hmm.
And moves it. So it shifts the troponin to the binding sites to be opened for the actin filament to attach, thus completing what is needed for muscle to contract.
Hmm. All right. You wanna state it over again so I can just get a better idea one
Okay,
more time.
let's go from the beginning, right? So
Mm-hmm.
the electrical impulse travels down to the synaptic gap. But we
Mm-hmm.
know that the electrical impulse cannot cross that gap, right?
Mm-hmm.
So
So
it
it
creates the
releases.
release of a tetrachlorine or ACH, which
Yeah.
could cross that gap,
Mm-hmm.
right? Now, as it crosses that gap, it opens the sodium gates,
Mm-hmm.
right? Sodium has a positive charge. So when it comes in
Yeah.
the cells, that means the cell becomes positively charged,
Mm-hmm.
right? This positive charge is called an action potential,
Mm-hmm.
right? And this action potential travels down your T tubules to your cytoplasmic reticulum.
So action potential. Mm. Okay.
Right?
Mm-hmm.
So now your cytoplasmic reticulum is where calcium is stored, and we know that calcium is needed for muscle contraction.
So with the T tubules,
Mm-hmm.
it is going in sarcoplasmic reticulum,
Yes.
and it sends it sends a signal for to open or to release calcium
Yes.
or open. Okay.
Right?
Mm-hmm.
Right. Now calcium goes directly to troponin, with me,
Mm-hmm.
right? And moves troponin, which in turn moves tropomyosin.
So calcium is help move troponin, or calcium goes to troponin
Mm-hmm.
and moves trypomyosin.
Like as we saw in the video, right?
Yeah,
Tropomyosin is connected to troponin. We saw that, right?
yeah.
And we also saw that tropomyosin is responsible for blocking the binding sites to keep your muscles relaxed, right?
Mm-hmm.
Right. So when calcium moves troponin, it moves tropomyosin, and that way it opens up the binding sites for the actin to attach.
All right.
You need me to go through that one more time, or we're good?
Nah, good.
Okay. Now, since you know you have everything down packed, you wouldn't mind a little pop quiz, right?
Maybe see how you do.
Okay. So we're going verbally, right?
Yeah.
All right. So, what are the different types of muscles and their characteristics?
So we have skeletal muscles,
Right.
cardiac muscles,
Yeah.
and smooth muscles,
Right.
right? And the skeletal muscles
Mm-hmm.
are involuntary
Yeah.
and have a
Wait. Which muscle is involuntary?
no, skeletal muscles is voluntary.
All right.
Yeah. Skeletal muscle is voluntary and has a striated appearance,
Yeah.
right?
Mm-hmm.
The cardiac muscles,
Mm-hmm.
like we found in your heart, and these things. Um, this is involuntary,
Right.
and it also has a striated appearance.
That is correct. Next.
The smooth muscles.
Mm-hmm.
This is also involuntary
Right.
and has a unstriated appearance.
That is okay. So next one.
Right.
What are the 5 properties of muscles? You don't need to explain them, just list them out for me.
5 properties of muscles.
Yes.
So contraction,
Contractility, but okay.
contractibility,
It's all right if you can't pronounce it. I'll take contraction.
extractability,
No.
the ability, extensibility,
Right.
adapt, adaptability,
Yeah.
um, the one which is spun, that is ex extract,
No. That would be excitability.
excitability,
Yeah.
and I can't remember the next one.
Come on, give it up. Just,
Contract, excitability, sensibility, adaptability, oh yeah, yeah.
Come on, you know.
Nah,
Come
that
on.
one not coming to my head.
Okay, so that would be elasticity.
Yeah, elasticity. What? Jesus.
Elasticity,
Yeah,
and that is the ability.
that would deal with to come back to its normal form after.
Okay, so last question. Explain for me, or give me a breakdown of how muscle contracts.
Wow. So muscle contraction. So it sends a electrical impulse, right, to the synaptic gap. Synaptic gap. Now in here, now this it cannot, the electrical impulse cannot pass through that, so it releases ACH, right?
Yes.
So ACH opens, well, ACH goes down to, no, ACH opens the, let's call that again. So, not, oh gosh, let's call that bridge or the site. All right, so ACH opens sodium gate.
Yeah.
Which sodium? The sodium is a positive charge ion, which gives it the opportunity for action potential for muscle contraction.
Mm-hmm.
So the action potential goes on the T tubule and enters the psychoplasmic reticulum.
Psychoplasmic reticulum.
Yes, psychoplasmic reticulum. Right. In there, it sends a signal to release calcium.
Yeah.
So calcium calcium attaches itself to troponin and moves trypomyosin.
Yeah.
Trypomyosin moves, yeah, and that is how you just get a muscle contraction. I guess it. I think.
Okay, so you left out one, which is the actin filament. So the actin have to attach in order for the muscle to contract, right?
Oh, right, yeah. So the actin after attach, yeah.
All right. So that is it for today on the muscular system. We will continue some at a later date.
Moisha called me.
Huh?
I can't get what
And,
I'm
that is it.
Right now.
Thank you.
Oh.
And
Mm.
I'll continue.
This girl called me about
All right.